Hi, this is John. I wanted to respond to my friend Tammy who tagged me in this post. My thoughts are that any system or anything that you can do that's different, that can help students understand a concept more effectively, that's awesome. Some kids don't think in terms of numbers very well. It is abstract information. Rote memorization is important. I mean, that can help you get those fundamentals down, but there's not a base understanding underneath it very often times, and some kids get lost with that. So any method like this what's being shown with the lines can be helpful to get certain students to have a better understanding of a concept. Now that said, I do believe that there is a far better way to teach multiplication besides just this method or the rote memorization, because the limitation on having these lines and drawing the lines isn't so much the time that it takes, but that it's only used for multiplication. It can't be used, that system really can't be effectively used for showing addition and subtraction, division, or algebra later on. What I do recommend, and I've just found a sheer joy in learning more about, is something called Mortensen's More Than Math. And what that does is uses manipulatives to actually teach you the concepts. And so the idea essentially is that all we do in math is count and build rectangles. There's a little more to it than that, but we have our different places. We have ones, we have tens, and we have hundreds, right? So there's our unit. We have 1 through 9. Our tens are basically just made up of 10 ones, and then our hundreds are just 10 of these tens, all right? So when we've got a math problem like 21 times 23, all we're going to do is build a rectangle out of that. So in this case, the very first example that was given on there, we have 21. So we put 21 across like this, and then we're going to build, so we got 10, 21 by 10, 20, 1, 2, 3. So again, we're just building a rectangle, but we got a hole in our rectangle. So what we need to do is fill that in. So what we're going to do is just take more blocks, fill this in here like so. Oh, now we got a little hole over here. So let's fill that in. So all we've done here is build a rectangle out of 21 by 10, 20, 1, 2, 3. And what we can do to solve for that is just take our pieces out. So how many ones do we have? Units. How many tens do we have? And how many hundreds do we have? So we know the answer just by looking at it is 400. And then there's 1, 2, 3, 4, 5, 6, 7, 8 tens. That's 80. And then we have 3 ones. So the answer is 483. Really simple. Now when we get into larger problems, it becomes a little tricky to use blocks like this. So what we do is we can actually scale them down. Here, this is a 100, but so is this. It's just a smaller 100. And then we've actually got 10 of these 100s coming together, which makes a 1,000. And then we've actually got more of these guys, even more of these guys. We've got 10 1,000s that come together to make a 10,000, all right? But we can't always take around these pieces. So one of the things that we can do to make this easier is we can also draw this. It's really better to get your hands on the blocks, but we can also draw this to come up with solutions. So to solve this problem in Mortensen's math, what we're going to do is use rectangles, because the idea is that in math, all we do is count and build rectangles. So we're going to remember that we have different places for the numbers. We have ones, there's tens, 100s, thousands, and 10,000s. And the position of the number tells us what place it's in. And then the unit tells us how many of those that we have. So do we have, how many 10,000s do we have, how many 1,000s, hundreds, and so on. So what we're going to do is basically start with this unit. That's a 1. It's just a little green dot. And then if we take 1 and stack 10 of those up, 1 by 10, we have a 10. And if we take 1 and stack up 10 tens, or 100 ones, we get a 100. If we take 10 tens and we stack that up, this is another way to represent a 100. So there's 2 ways to make a 100. We can make a 1 by 100, or we can make a 10 by 10.
to get a 1,000, that's basically 10 times 100. So there's 10 100s in there. That's a 1,000. And we could take 10 1,000s, or we could say a 100 by this way and a 100 by that way, and that is a 10,000. So there's our building blocks for this problem. So what we do when we try to solve a multiplication problem like 123, remember we've got 100 here. Okay, that's a 1,000, so it's 100 tall. And then there's our 1,000, and it's 10 by 100, so there's 10. This is 10, and that's a 100. It's 1 by a 100. So what we're going to do is just count this side of it. That's 110, 23. So there's 123. And then when we take the other one, 321, there's 100, 200, 300. There's 10, there's 20, and 1. So that's 321. And all we're going to do is turn that into a rectangle. So 123 this way by 321 this way. Oh, but you know what? We've got a big hole up here. I'm going to shortcut filling this in for you, but just to show you what that looks like, we now have our filled in rectangles. So we just added in the 1,000s that were missing. We added in some 10 by 10s to make the 100s, and we added in 100s here, and then we added in some 10s, and then we added in the units here. So all we have to do is figure out how many of each one of these we have. So with our units, we basically got 3 1s that are over there. So we're just going to write that number here, 3. And then how many 10s do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 10s. And then we need to count our 100s. How many 100s do we have? Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. So 10 100s is the same as a 1,000. Okay, so we're going to add that number over to our thousands here. But how many do we have left? We have 1, 2, 3, 4. So there's 4 100s left. So we knew that there are 10 100s made a 1,000. So there's one extra 1,000. So we're going to start with that one, 1. And then we go 2, 3, 4, 5, 6, 7, 8, 9. There's 9. And then how many 10,000s do we have? We have 3 of those. So there's our answer, 39,483, which basically means 3 10,000s, 9 1,000s, 4 100s, 8 10s, and 3 1s. And there's our answer. Now, what's also cool about this is that this also paves the way for more advanced math later on. So when we talk about, if this little, these are units, right? This is an x. We could say 10 is an x. This is an x square. You take 10 by 10 and you get 100. This is an x cubed. 10 by 10 by 10 is 1,000. If you take 10 times 10 times 10 times 10, that's a 10,000. Or we could say x to the 4th. So what this can turn into later on is laying the foundation for how many 10,000s do we have there? There are 3 of them. So we could say that's 3x to the 4th plus how many 1,000s do we have? 9. That's 9x to the 3rd plus how many 100s do we have? That's 4x squared. And then how many 10s do we have, or x's? Plus 8x. And then what do we have left over? There's our units, plus 3. And then we can get into doing some really amazing things. So what we could also look at this as is this is this one side here is, that's a 100, so it's an x squared plus 2x, I ran out of room, plus 3 there, times, what's on the bottom here? That's a, it's how many x squareds? There's 3x squared. Well, I ran out of room. We'll put it up here. That's a 3x squared plus 2x plus 1. So if you take those numbers, what you're learning is that's an x squared plus 2x plus 3 times 3x squared plus 2x plus 1 equals this big giant number up here. Okay? So that's something cool that Mortensen's math allows you to do, is to go beyond just the basics of multiplication, because using this same system with the blocks, you can learn addition, subtraction, multiplication, division, fractions, algebra, and even calculus. And it's all contained in one system using these manipulatives. And it is best to get your hands on the little blocks, drawing in, once you get better at it, you can start drawing them like this, but that also gives you the foundation to understand laying out the numbers and writing them out as well. And then you can also learn to solve the problems like that, but you've got a fundamental understanding of how these things actually work in the real world. It's no longer just an abstract thing or something that you've memorized without the understanding. So I do strongly suggest that you check into Mortensen's More Than Math. And the guy I really like that teaches this, his name is Crouton Ramon's House of Math, and you can Google search that to find his website. He's got a lot of really awesome free videos on YouTube as well.